Here's problem 3836. Light strikes flat water surface, index of refraction 1.333 at the Brewster angle. Calculate the angle between the reflected and the refracted wave. So let's say we had a water surface and we had light coming in to that surface, so it's going to reflect off like this, and we have a normal this way. So we're going to have reflection and a refraction. And so here's our incoming angle, which would be reflected at the same angle from the normal. And that actually would be our Brewster angle, because we're told that we're at the Brewster angle. So the index refraction of the water should be equal to the tangent of the Brewster angle, theta p. So in other words, theta p is going to equal the inverse tangent of the index refraction of water, which is going to be the inverse tangent of the 1.333, and that is equal to 53.06 degrees. So that is our reflected angle. The refraction is going to be dependent upon Snell's law. So we should have that n1 sine theta 1, in this case the Brewster angle, should equal n2 sine theta 2. We want to solve this for theta 2, so theta 2 is going to equal the inverse sine of n1 divided by n2 sine theta 1. So this is going to be the inverse sine of, now n1 is our first substance, which is air, that's 1.0, and n2 is the water, 1.333. So we're going to have 1 over 1.333 sine 53.06 degrees and what does this give us? 36.84 degrees. So that's theta 2. So we got this angle and this angle. If we were to add those two angles together, we would have our total angle there, which is our theta reflected, which is the Brewster angle, plus our theta 2 here, which would be 53.06 plus 6.84, and that's equal to exactly 90 degrees. So those two angles are 90, leaving us with a supplementary 180 total, which means that this angle right here, the angle between these two rays, must be, let's see, the angle we want is equal to the total angle, 180 degrees, minus these other two angles of 90 degrees. And that's indeed is going to be 90 degrees itself. That is going to be a right angle, as it should be for all Brewster angles. The reflected ray will be perpendicular to the refracted ray. You could prove that relationship by working this problem in general in reverse algebraically, but this kind of proves it just using numbers. 90-degree angle between the reflected and the refracted ray.